The method of solving for constant infiltration rate using the phi index involves trial and error. Check how it is done here in hydrology. For a certain water basin, if precipitation occurs, there are water losses and possible runoff if the rain is ample enough. In order to compute for the runoff, we need to make the infiltration constant. This is done in three methods. The first is the phi index, with the concept that the rainfall volume is equal to the runoff volume. The second is the F-average method, taking the average infiltration loss throughout the storm duration. The third is W-index, which takes the infiltration rate during the time the intensity is more than the infiltration capacity rate. Let's delve into the phi index deeper. This index computes for the infiltration rate from the rainfall excess, which is taken as equal to the runoff volume. This method uses the hyetograph of the excess rainfall. So to place the description into a mathematical sentence, we can say that phi index is the ratio of all losses due to infiltration and the duration of the rainfall. From the graph, we take the phi index as the pink area over the duration of the rainfall. Now to correlate the phi index with the runoff. The rainfall volume less the phi index by the duration of the excess rainfall is equal to the total direct runoff. This is written as P minus phi times T is equal to R. By transposing R and phi times T to the opposite sides, then divide the expression by the time, we take the phi index as the difference of the precipitation and runoff all over the duration, or that is P minus R over T. And since there are different entries at various times, we can write the runoff as the summation of P minus phi times the duration. The procedure of looking for the phi index is by trial and error, which means expect a number of iterations until the final value is verified to be correct. The first step is to count the number of pulses. This is just the number of entries in the record. Next is to look for the value of phi, using the function we discussed earlier. Check the number of entries giving excess rainfall. If there is a discrepancy between the impulses, repeat the procedure. The second example includes a record of a 4-hour storm over a 50 square kilometer catchment. With a total direct runoff volume of 1.5 million cubic meters, determine the phi index assuming other losses are negligible. The first thing to do is to place pulse numbers to each entry of the record, then illustrate the hyetograph. A hyetograph reflects time versus storm intensity. These are exactly the parameters provided. However, check that the rainfall intensity should be interval and not accumulated. So from the third column, the values of intensities are 8, 15, 10, and 5. They rise and fall, which means they are not accumulated, they are interval. So these values can be plotted readily in the hyetograph. With 1 hour intervals, draw the bars starting with 8 millimeters height, then 15 millimeters, next is 10, and the last is 5. The second step is to solve for the phi index. The first trial considers all the 4 pulses, which has 4 hours duration. From the function, we make this P minus 4 of phi as equal to R. Both P and R are still to be computed. The precipitation is the area of bars, so take the summation of the intensity, then multiply the duration of 1 hour, thereby having 38 millimeters per hour times 1 hour, having 38 millimeters. For the runoff, the given value is 1.5 million cubic meters. Take the depth by dividing this by the catchment area, which is 50 square kilometers. This is converted into meters by 1,000 meters for a kilometer. Then multiply another conversion of 1,000 millimeters per meter, giving runoff as 30 millimeters. Plug these values into the function, making it 38 minus 4phi as equal to 30. And by transposition, phi turns to be 38 minus 30 upon 4, which is simplified as 2 millimeters per hour. If we plot the phi to the hyetograph, it shows that all 4 bars actually have runoff, so the assumption is correct, and the phi index is 2 millimeters per hour.